All right, so this is just a quick little video. You might run into the situation where you might get an answer like x equals plus or minus a radical 9 halves, or 9 over 2. That's a pretty awful looking 9. Let me try that again. So 9 over 2. That's better. Okay, so I wouldn't leave it like this. You always want to try to simplify if possible. So I would take a look here. So you can actually reduce this by writing a radical on the top and on the bottom. So rather than like having 9 over 2 under one radical, you can split them to a radical on the top and the bottom. It's one of the rules of radicals. All right. Now some of you might say, oh, I already know what radical 9 is. That equals 3. And you'd be correct. Okay, so plus or minus 3 on top. But radical 2, if you actually try to type into a calculator, 2 is not a perfect square, meaning you get a decimal of some kind. So let's just go ahead and leave it, because I want this to be an exact answer. Now, you can't leave your answer like this because I can't have radicals on the bottom, okay? Just like one of the rules, whenever I write a final answer, I can't have negative exponents typically. I need to make sure they're positive exponents. I can't divide by 0. That means undefined. So one of the things that in math, to make sure it actually looks clean and the answer looks nice, we can't allow radicals in the denominator, okay? And so there's this process called rationalization. It's a very fancy word. Okay, I'll write it up here. Rationalization. So that could be a great word on Scrabble for those of you looking to really up your game there. Anyway, so rationalization is a fancy word, but it's actually something you already know how to do. Okay? So we're going to take a pause from that one up there. I'm going to do a little mini example below it here. All right, so let's say I have... I'm trying to pick the right color. Purple, sure. Okay. Let's say I had 1/3 minus 2/5. Okay. So 1/3 minus 2/5. Actually, that's a bad example. Let me try this. I'm going to stop here. So 1/3. All right, but I wanted to make this something different, right? 1/3. What I can do with it is, if I wanted to, couldn't I multiply both top and bottom by 2, so multiply straight across. 1 times 2 is 2, 3 times 2 is 6. 2/6. Now you might say, okay, 2/6. Is 2/6 the same as 1/3? Yes, these are the same. They're the same exact thing, right? Like all I did was multiply both top and bottom by 2, and I got the same fraction. Of course, you might say, well, I can reduce 2 over 6 to equal 1 over 3. Correct. So it's still 1 over 3. It just, we wrote it to be different and has a different denominator, but it's still the same fraction. It just has a different look. Okay? So, another example, again, if I had, let's do 12 over 4, right? Now you might say, well, I can divide both those by 4, so divide by 4, divide by 4. 12 divided by 4 is 3, 4 divided by 4 is 1, 3 over 1. Which equals 3. Again, this fraction and this fraction are the same, correct? They're represented with different numbers, but 12 over 4 is the same value as 3 over 1. Okay? So, and that we just call that making a common denominator when we add or subtract. Okay? What you can, so just keep that idea. So when you're thinking about rationalization, it's not complex. All right? So, like I said, that radical 2 on the bottom, I can't have that. I have to get rid of it. So rather than out of like, oh, well, I need to change the denominator, I actually have to get rid of it. And the way we get rid of it is by multiplying the fraction by the, so if radical 2 is the problem, multiply by radical 2. But of course, whatever I do to the bottom, we got to do to the top. Just like how I did with 1 over 3 times 2, or 12 over 4 divided by 4, right? So my issue was the radical 2, so I'm going to multiply by radical 2. If I multiply straight across, this gives me 3 radical 2 over, and radical 2 times radical 2 equals radical 4. Here's why I did that. Can I now simplify radical 4? Yes, I can. Radical 4 just becomes simply a 2. So 3 radical 2 all over 2 would be the way I would write this answer. Now, again, they're the same. I'm just writing it differently because in math, I can't have a radical in the denominator. Just can't have it. Okay? So notice how when I write that 2, it's no longer under a radical. It's just a regular number, which is perfect. Okay? So here's another example, just to kind of give you something more to look at here. So if I have plus or minus, let's see, 7 over 3, right? So like I explained before, you can write it in two different radicals, radical 7 over radical 3, okay? And remember, I can't have a radical on the bottom, no. So I need to multiply this by the issue. So I'm going to multiply radical 3 on bottom, radical 3 on top. Again, multiply straight across, which if they're both inside the same radicals, because these are both square roots, 7 times 3 is radical 21. Radical 3 times radical 3 is radical 9, which radical 9 becomes a 3, and 21 just stays 21 because you can't simplify it. All right, so my answer, again, plus or minus radical 21 over 3, is the same as this answer right here. They're the same thing, I just wrote a little different. Okay, but the difference is I got rid of a radical in the denominator because I used a process of rationalization. Okay, so that's just a tutorial on how rationalization works.